Hello, my name is Gerard Campo. I'm the president of the GEMA Sciences Inc. Today we're going to do a demonstration of our on-demand hydrogen system. This is our test rig that we're presently using. It's a high pressure tank, but today we're going to run it to about 100 psi. The system will be automated in the future. That's what we're working on presently, where there's an automatic fill. What we have in here is our material. This material is elemental in that there is no chemicals involved with this process. This is all elemental material. We are going to fill this reactor with approximately 300 grams of water, basically about half of a bottle of 500 ml. Is what we're going to fill it up with today. Okay, we have a limited fuel cell today. We do have a 500 Ballard fuel cell Ballard here, 500 watt. But today we're going to run it with a 12 watt fuel cell, just to give you an idea of performance and output. We have a load cell which will match the amount of power that the fuel cell is producing. And it will show up on our screen as voltage, current, and total watts. We will also show you the pressure that this material will build in our reactor, and we will show you the temperature here through this thermocouple of the amount of temperature or thermal energy, because it is an exothermic reaction that it will produce. So what we do primarily in our testing is we fill our reactor with water. This will be all automated in the future. And we place this on a shelf. And the reason we place it on a shelf, because it's very reactive, it starts right away. So once we have that on a shelf, we close our reactor. Again, this will be all automated in the future. None of this will be needed. But this is how we're doing it now, because our primary purpose today is to show you the material. The applications or the reactor that processes the material is in development. Presently, we're looking at something basically in the 2-foot range. High, 6-inch diameter, and we can power a 500 watt fuel cell with that. So we're looking at a weight ratio of potentially 100 pounds of material and water combined with the reactor to run a small vehicle. We'll just give it some time here. It'll start building pressure.
There won't be any power output yet until the valve is turned for the hydrogen to go through the fuel cell. We're just watching the temperature rise inside the canister as the pressure is building.
Now this is the initial reaction. It takes time for the initial reaction to operate, but once you continue feeding the pellet uninhibited by any covering, you will get a much quicker response as far as hydrogen production and pressure.
You can see that gauge is building quickly. We're already at 50 psi, 60, 75, 80, 90.
Okay, so we're at 100 psi. I will start the fuel cell. Now there's a fuel cell. And you can take a look at the screen and you'll see roughly about 9 watts of production, 9 to 10 watts. Now you'll also see the fan running. The fan requires about 3 watts. So right now our production is about 13 watts. Now I want to keep within spec of the fuel cell that we're operating. So we're a little high on the spec. It is a 12-watt fuel cell, but we'd like to keep it at about 8 watts. You run fuel cells between 20 and 50% of duty cycle, believe it or not. So a 100 kilowatt fuel cell is best run at approximately 50 kilowatts. You don't like to run it higher. You lose efficiency if you run it higher. So we like to keep it within this 6 to 8.
And the canister temperature there right now, Gerard, is 114?
114 Celsius, yes. And the pressure is 110 psi. Now this will run in this condition roughly about an hour. Our testing has showed it runs about an hour to 60 minutes to 70 minutes of production. And we would try every, depending on your load, if it's a much higher load, 100 watts or 200 watts per hour or 300 watts per hour, you would obviously be consuming a lot more hydrogen and you'd have a much larger fuel cell. As I said, to give you an idea, this is a 12 watt, this is a 500 watt. So the size is not that much bigger for an increase of 50 times the amount of power output. Now this is a Ballard fuel cell. This is a Horizon fuel cell. These are made in Singapore. These are made in the US by Ballard Power in Vancouver. We also operate the Ballard. As you can see, the Ballard doesn't have a fan on it. We don't use fans on Ballards. We can outfit it with a much simpler. They support it as a skeleton fuel cell. But you can see the consistency we're getting in the output. And as you can see, we're actually increasing in pressure. Our pressure has gone up actually, so we're still producing hydrogen internally. Even though we're consuming it, we're producing more hydrogen than we're consuming right now. And we're up to 115 Celsius as far as the core temperature. And this is a stainless steel vessel, and we have a thermocouple on here. It is hot. This can be used as a dual utility. We can use it as a heating vessel for a house to provide hot water for the house, as well as hydrogen fuel that can run obviously through a fuel cell, through a reciprocating generator for a lower cost. We can basically use it as a burning gas for cooking or for a furnace.
Or store it for a vehicle.
Or store it for a vehicle. With a compressor, a compression system, we can store it in canisters and use it on vehicles. Now, ideally, what we want to do is we want to build a small reactor this size for smaller vehicles initially, but our primary focus right now is the military. Our feeling is we can offer them a green, completely green system. As I said, this is an elemental material in here. There's no chemicals. It's benign, inert, and is GHG free. Now we're continuing to run even higher pressure. So you can see the power potential of the technology. Now what we installed here, again, just to recap, is around 275 mils of water and approximately 18 grams to 20 grams of material. And the reason I say 18 to 20 is because we had a wrap around it and I didn't weigh the wrap. But I know roughly the pellet size we produce right now. The pellet size can be anywhere from 5 grams to 10 grams. We can go much larger pellets as well for longer lasting, but you have to proportion the mechanism of delivery as far as the automated loading system to the pellet diameter. So that's something, again, in the future we're working on, and we're trying to develop these systems and trying to raise money in order to accomplish that. Now, as far as filtering, as you can see, we have 2 simple pneumatic filters here. That relates to the purity of the hydrogen we're producing. Our purity right now is around 99.9% at this point. And once it goes through the water filters, it achieves approximately 4 nines to 5 nines. 99.99% purity, which is purer than most hydrogen today, unless it's filtered extensively. And that's what our electrochemical reaction is creating here in this canister using water. And this is simple tap water that we use today. And as you can see, our pressure is still holding, and we're well into this experiment. We're 18 minutes now, and we're still holding that pressure. So we have a long way to go before we exhaust our fuel. And remember, our fuel is water. Now, we are also working on, in the future, the ability to take our technology and apply it to crude oil. Because crude oil has a much larger hydrogen chain, approximately 17, 18 hydrogen atoms, compared to water that has 2, our feeling is we can create hydrogen from crude oil and leave the carbon behind. And that's something we're also working on, but we're a small company and we're trying to develop these technologies, and it's taking time.
I'm just going to set this down and just let it.
Sure.
It can.
Yeah. So our pressure is constant at 100 and
About 110 there, isn't it?
yeah, 115 psi, and we haven't in 20 minutes we haven't dropped. And we're at 7 watts. Now, if this was interactive, I'd take your questions at this point. But unfortunately, it's not. Hopefully in the future it will be. Hopefully we've piqued your interest, but you can see what we've developed. We started, just to give you a history, 2 years ago we started with a cathode anode. So 2 separate membranes put together created hydrogen. And then we developed over time the methodology and the working parameters for a single cathode anode combination. And what we use is a very economical method of manufacturing, a nanotechnology that's very specific and very easy to formulate. No clean rooms are required. No special equipment. This can all be fabricated in a standard plant. Some of the equipment may have to be customized, but we can take existing equipment out of the marketplace that's already being manufactured and repurpose it for the production of these tablets. Presently, we have enough material, component-wise, to produce about 5 million tablets. We have access to the materials. We have some that we've purchased. And we are, again, looking for investment to take this technology to the next level. But as you can see, our pressure is still at 110, and we're well into our consistent output. As you can see, is around 7 watts. And again, completely scalable. The system in the future will have an automatic loader. It will measure the pressure and the demand. We would have some sort of fuel cell and possibly a secondary small battery system. That battery system would be charged, and we would have what we call an accumulator adjacent to this reactor. That accumulator will accumulate a reserve or storage of hydrogen at low pressure, 30 to 40 psi. The sensor on the accumulator will determine the pressurized hydrogen within the accumulator, and the reactor will automatically turn on when that accumulation is dropped down and demand is high. And the system will completely adjust to where it needs to be in order to facilitate all the energy the client will require.
What's our temperature? Still 98 degrees?
Yeah, 100 degrees C.
So in a large system, you would have quite an offtake of heat there also.
Yes. Yes. Yeah. We would run some sort of a heat exchanger off the reactor and continually recycle that liquid until it reaches optimum temperature of 100, roughly, well, obviously 100 degrees C is too hot, so we probably operate at 140, 145, which is a typical water heater temperature. It mixes with water.
Is there any advantage to putting a tag rate on there?
There may be.
Yeah.
There may be. So, but I don't like muddying the tech.
I agree.
The tech is what it is.
No,
now,
I
as you
agree.
can see, we're at 105 psi, and we're almost 25 minutes into this demonstration. And our wattage, again, is extremely consistent. Once this is set up, you can see this dial has not moved in 15 minutes. It is completely consistent in its output and performance and what it produces. And this is on demand. And this is the difference. This is green on-demand power using hydrogen.
Remotely.
Remotely, we can ship these tablets anywhere as long as the client has either urine or sewage, gray water, or rainwater, tap water. They can produce hydrogen at location and heat at location and supplement any other energy that they may have that's variable based on the weather. See, solar, wind. This negates the requirement of having a generator in the wintertime to top up your batteries because your solar is not working. This is an excellent idea or a facilitator for a supplement or a companion to green power. And our feeling is once we get to a point that we can demonstrate this on a larger scale, government will come in and subsidize our cost because it will cater to exactly what the government is looking for the north or remote locations. They're looking for green supplements for diesel generators. Now, we believe that initially what we can do is we can build a small system that goes on a genset, a diesel genset, and cleans up that genset. And that will gently prod the government in understanding the technology with some history without a radical change to the system they have set up now. And that will complement the diesel by cleaning up the emissions on the diesel. That will give the government a good indication of how clean and how reliable this technology is. As you can see, the only moving part we have in this entire system is that fan. Everything else is mechanical. And we can build this to be completely mechanical. The only other devices that we would use are solenoids, opening and closing, and obviously a fan. Other than that, everything else will be mechanical.
We can just let that run out there for a bit, Gerard, and
Yeah.
they can just sit and watch there.
And as you can see right at the top here, you'll see the water being formed. And that is the only exhaust, is water being formed from our fuel cell. And again, if you look at the screen, you'll see how consistent this is. That has not moved. And we are still at 100 psi.
Yeah, it's impressive.
So we're data logging all this, as you can see. On the right here, this is all being data logged. And that's presently what we're doing for the DND. This is our setup for the Department of National Defense to facilitate proof of concept to them.
Approximately how many times have you repeated this experiment, Gerard, with the data logging?
20 times so far.
With similar results every time. Yeah.
Yeah, similar results.
Yeah.
Yeah, very consistent. Again, our formulations, we're playing with our formulations on a constant basis to determine best practice, best performance.
Pressure just starting to drop a little bit there. Yeah, I think we started this up. I think the capsule probably dropped in about maybe I think we were about 5 minutes in, so that's 23 minutes ago. Yeah. We're still at 6.846 watts.
Yeah, plus the fan. So we always include the fan because everybody says, well, that's not a lot of power, but when you're only talking about 10 watts, the 25% of the power is going to the fan. On a 500 watt system, you've got two small fans, and they're only consuming 2% to 3% of the actual power being produced. This fan right now is consuming 25% of the power being produced because it is a small device. So that just gives you a perspective of power consumption in this demonstration.
Wattage holding consistent.
It's very consistent. Very, very consistent. That's one thing about fuel cells. The power output is once you're feeding the hydrogen into them, they're absolutely, there's no.
We're sitting about 90 psi now.
So we're still at around 91 C on the heat. Nice and hot. As you can see, we have a burner here as well to show, may possibly later on, a completely clean burning flame. You can actually not see the flame when we light it. we have to put a piece of paper on there to actually show there's a flame there. If you put your hand there, it gets extremely hot.
Could we show that before the end of the...
Sure.
Should we?
Yeah, we could do that.
Because I think we've shown well what it's doing here. We know it's going to drop off at a consistent basis, because once that drops off to a certain PSI, you have to open that valve more and allow more.
Once it gets down to about 5 or 10,
Okay.
I have to adjust the valve
Okay.
to keep the consistency.
Maybe once we get down to maybe 30 PSI or something, maybe if we just...
Sure, we can exhaust the rest through
Yep.
burning.
Yeah.
Are you picking up the wattage?
I think it should be. I think when it's on a computer screen, I think they'll be able to see that.
So we're into 32, 33 minutes here, and again, you can see how consistent it is, the output.